From its perch, 350 miles above Earth, NASA's Hubble Space Telescope surveys the universe. In 2002, Hubble found black holes in unexpected places, helped in nailing down an age for the universe, and was reborn with sharp new eyes. 2002 was a busy year for the world's premier telescope. Our solar system. Though we have studied it for centuries, Hubble reveals even more with each new image. In 2002, a pair of Hubble discoveries brought us to an area of the solar system we barely understand. A broad region just beyond Neptune called the Kuiper Belt is home to billions of icy worlds left over from the solar system's birth. Here, Hubble found twin Kuiper Belt objects that are helping us understand more about this mysterious region.
When we find binary objects, as astronomers, we get very excited because that enables us to use the laws of physics to derive interesting things about the system. We can figure out how massive it is. By discovering that this was a binary object, we discovered a new tool for analyzing what's going on in the Kuiper Belt.
Another science team used Hubble to confirm the largest of these ancient vestiges to date. Named Quawar, after a Native American creation myth, this Texas-sized ball of ice and rock is a milestone in our exploration of the solar system.
This is one of the largest objects found in the solar system since Pluto was discovered in 1930, and it shows that there's a large number of very big objects that are still out there in the solar system yet to be discovered.
We're just beginning to understand the outer edges of our own planetary neighborhood.
For me, one of the most interesting things about this is that we're using Hubble and its exquisite resolution and its sensitivity to really look at a frontier region of our solar system. Often we think of astronomy about the big discoveries in cosmology, but there are parts of our universe close to us which we know very little about. And again, Hubble is playing a role in understanding what's going on there.
From our solar system to worlds beyond, Hubble led the way in understanding planets that orbit other stars. In 2002, Hubble measured the mass of Gliese 876b, determining that it is roughly twice that of Jupiter. Thanks to telescopes like Hubble, in just a few short years, we have gone from speculating about the existence of other solar systems to understanding what these alien worlds are really like. Black holes are among nature's most intriguing objects. Their incredible mass creates gravitational energy so strong that anything that gets too close will be swallowed up. Even light cannot escape. Relatively small black holes form as the remnants of large stars, while supermassive black holes lurk in the hearts of most galaxies, including our own Milky Way. But are the small ones somehow linked to the giant ones? Hubble research suggests they are. Hubble scientists aim the telescope at globular star clusters, dense packs of stars, in the hope of finding black holes in their cores. Finding them in star clusters may help us solve an astronomical riddle.
The announcement that you're about to hear today is critically important because it addresses the age-old question of what came first, the chicken or the egg. We now believe that galaxies, virtually all galaxies have black holes in the center of them, but we don't know what came first, the black hole or the galaxy.
There exist black holes in the centers of globular star clusters. This result is important for several reasons. First of all, globular clusters were not expected nor previously known to have black holes in their centers. Second of all, it now appears that black holes may be even more common in the universe than previously thought. It turns out that the ratio of the mass of the black hole to the mass of the cluster is similar to what is typical for galaxies.
Finding black holes in the cores of dense star clusters suggests that galaxies may have formed when these clusters merged in the early universe. So the eggs, mid-sized black holes within star clusters, seem to have come before the chickens, today's immense galaxies. One of Hubble's key projects has been to learn the age of the universe. Previously, Hubble astronomers used variable stars in distant galaxies to measure the universe's expansion rate. By understanding how fast space is expanding, they hope to trace that expansion back to the moment of its birth and establish its age. Another way to find the age of the universe is to look at some of the oldest known stars. That's what a team of Hubble scientists, led by Harvey Richer, did.
We're here today to announce a new determination of the age of the universe, with a technique that hasn't been used very much before. The result is that we believe the age of the universe is about 13 billion years. And the way in which that result was obtained was by looking at the coolest white dwarf stars that we know of in the universe.
White dwarf stars are the remains of stars that long ago stopped burning and are like coals left over from a campfire. By determining how much they have cooled, you find out how old they are. This new result agrees with other findings using different techniques. Because these fading stars are so close to brighter stars, examining them proved difficult. Hubble made it possible.
They're very close to other bright stars in the center of this ancient star cluster. There's lots of scattered light. Without the tremendous imaging quality of Hubble, it would not have been possible to isolate these incredibly faint objects in the center of the star cluster.
"10 million Americans haven't been able to enjoy Hubble's tour of the universe. They're visually impaired, but thanks to a writer, an astronomer, and a school teacher, Hubble's universe came to their fingertips in 2002. Author Noreen Grice wrote an astronomy book for the blind in 1984, which inspired astronomer Bernard Beck Winchatz to create a similar book with Hubble images.
He saw my book in a museum store, and he thought, wouldn't it be amazing if we could do some kind of book like that for the Hubble Space Telescope? So he called me. And I thought about it, and I thought, why not use real pictures from the Hubble Space Telescope, but put a transparent tactile overlay on it? That way somebody could look at the picture and see it, and if they couldn't see it, they could feel it. It would be real pictures from the Hubble Space Telescope just coming to life in the book.
Students at the Colorado School for the Deaf and Blind became the book's field testers, making sure its tactile images could be understood through touch. For the millions of visually impaired around the nation and the world, Touch the Universe will change lives. Hubble is now ready to build on its discoveries as never before. In March 2002, astronauts aboard Space Shuttle Columbia captured the telescope in orbit. The astronauts replaced Hubble's aging electronic power control unit and its tattered flexible solar panels, brought its dormant infrared camera back to life, and installed the advanced camera for surveys. The new camera has improved Hubble's vision by a factor of 10. After a decade in space, Hubble is reborn, with new eyes to gaze upon the universe.
I think you'll see that people at the Space Telescope Science Institute, universities all around the world, amateur astronomers, young and old, will be able to enjoy the beauty and inspiration that these new pictures from Hubble will bring. I'm convinced that the next most incredible discovery from Hubble is one that's probably months, if not years away. And the work that we've done up here on Columbia is just a small part of what has brought us to the point of being able to make those discoveries.
With its new camera and power system, Hubble can see farther out into space and deeper back in time, and can bring us the nearby cosmos in incredibly sharp detail. In the coming months, Hubble and many other observatories will watch a dying star in the Carina Nebula. Eta Carina's outbursts happen with the regularity of Old Faithful, every 5.5 years. Astronomers expect the next outburst in mid-2003. Looking beyond our stellar neighborhood, Hubble will take part in a campaign to understand how galaxies have formed throughout time. Along with many orbiting and ground-based observatories, Hubble will look at early galaxies, star clusters, and intergalactic gas to test ideas of how the universe came to be the way it is today. And in 2003, Hubble's Ultra Deep Field project will use the new advanced camera for surveys to see farther than humans ever have. The new observations will go much deeper than the legendary Hubble Deep Field, perhaps shedding light on the mysterious dark energy that seems to dominate the universe's expansion. The Ultra Deep Field may also deliver one of astronomy's holy grails.
What we'd love to do is get back to the time when the very first galaxies were being created. That's a kind of holy grail right now for astronomy. That represents a distinct boundary in the history of the universe that we haven't seen but we expect to see. And we have a real chance of finding it with this deep field.
From the edge of our solar system to the beginning of time itself, NASA's Hubble Space Telescope continues to help us understand the vast cosmos around us.